A virtual network segment has all the components that you would find on a physical network segment. You have the virtual network adapters, you have virtual network switches, and so on. Let's take a look at how a virtual network works. Over here we have a typical physical network switch. We have traditional user desktops, all interconnected using the switch and standard UTP cable. But notice over here that we also have a hypervisor host. This hypervisor host is also connected to the physical network switch with a UTP cable, just like any other physical host would be. However, within the hypervisor, we have 4 virtual machines running. One option for configuring virtual networking for these virtual machines is to take their virtual network adapters and bridge them logically, not with actual physical cables, but logically to the physical network interface installed in the hypervisor host, which of course is connected to the physical switch. By doing this, each of these virtual machines then appears on the physical network as if they were a physical host, just like the systems over here are. The virtual adapter in each one of these virtual machines has their own MAC address and their own IP address. Therefore, they appear to be just a regular host on the physical network. This isn't the only option you have when networking virtual machines. In this example, we've created a virtual switch within the hypervisor. This is not a physical switch with real ports. Instead, it's a switch that's running as software in the RAM of the hypervisor itself. You can actually connect each one of these virtual network adapters and each one of these virtual machines to this virtual switch. We've depicted it here with what appears to be drop cables, but they're not really drop cables, they're just logical electrical connections using the hardware, the hypervisor itself, to connect the virtual network adapters to this virtual switch. By doing this, we've created a virtual network segment. Notice that this virtual switch is not connected in any way to the physical interface and the hypervisor at this time. Therefore, each one of these virtual machines can see each other on the virtual network through the virtual switch, but they cannot see any of these hosts out here on the physical network. This is sometimes called a sandbox environment. If you wanted to, you could actually connect the hypervisor itself to this virtual switch, so the hypervisor can interact with these virtual machines on the virtual network. But it still keeps these virtual machines themselves isolated from the physical network, and this can be a very valuable configuration, especially if you're in a testing environment. For example, suppose you're about to roll out a new patch to all of your physical servers. You could set up virtual servers connected to an isolated virtual switch within the hypervisor, and then test that update to see if it's going to break anything before you actually roll it out into your production environment. You can even create a router within your hypervisor. In this case, we've set up a NAT router that connects our virtual network segment to the physical switch through the physical interface in the hypervisor. In this scenario, we've essentially created a virtual network segment that goes to the NAT router and then out onto your physical network segment. In this configuration, all of these internal virtual hosts are able to contact these physical hosts out here. However, because we're dealing with a NAT router, we can't initiate connections in the other direction, of course, but you can go out in this direction. These hosts would be able to get out on the internet, for example, and download patches and updates. There are 2 types of virtual devices we can easily manage from here: virtual network adapters and virtual switches. Let's look at virtual switches. I'm using the client version of Hyper-V running on a Windows 10 laptop. Essentially, it's the same as the server version, but all virtualization programs have some type of virtual switch management. In Hyper-V, we go into Virtual Switch Manager. The virtual switch should exist before you create your virtual machines. In Hyper-V, we have different types of virtual switches. For example, I can make a private switch. I'll just click Create Virtual Switch. The private switch allows the virtual machines to talk to each other, and that's it. If I want to use an internal network, then my VMs can only talk to the other VMs. They can talk between themselves and talk to the host, but they can't get to the outside network. I could also use an external network, which does let the VMs use the host's network card directly. That means I'm using one network adapter for both the virtual machines and the host. If this were a server, it would be best practice to put in 2 network cards, one for the host and one for the virtual machines. I have a couple of private switches here, vSwitch 1 and vSwitch 2. I have an external switch, vSwitch Internet. After you set up your virtual switches, you'll want to connect the virtual network cards in the virtual machines to a virtual switch. Let's select Cancel down here. Let's look at the settings in this Windows 10 client and see what's happening. I have a network adapter already installed in this machine, and it's connected to vSwitch 1. If I'm using VLANs, I can enable VLAN identification here. Depending on your virtualization system, you might have other features. For example, I can enable bandwidth management so that this virtual machine can't take over the network card's bandwidth. I've also got some other features inside here if I expand the network card. Under hardware accelerations, there are some features I can configure. I also have advanced features. I can enable MAC address spoofing, which is required to support network load balancing. I've got DHCP guard, which prevents this VM from being used as a rogue DHCP server. I've got router guard, which prevents the VM from being used as a rogue router. Router guard also makes this a protected network. This means if this network is disconnected and this machine were participating in a high availability solution, the machine would fail over to the other node in that cluster. Port mirroring also allows me to send a copy of network traffic to another machine if I'm using it for monitoring. This is necessary to use products like TCP dump or Wireshark. And finally, I can use NIC teaming so that I can have a couple of these adapters in the guest operating system and connect them for additional bandwidth or fault tolerance.